Okay, so we are going to find the perimeter of the triangle created by the intersection of three straight lines. So we've got the equations y equals 6x plus 1, y equals 17x take 2, and y equals negative 9x take 4. So I've gone ahead and graphed those on Desmos so we can just see what that triangle looks there, and we can see the red line is shown. The red line is y equals 6x plus 1, the blue line here is 17x take 2, and the green line is negative 9x take 4. So what we're going to need to do to find the perimeter of the triangle, it's two different calculations that we need to do first, and we need to do each of them 3 times. So first thing to do is to find where each of these lines intersect each other. So we need to find 3 coordinates of intersection, and that's going to give us the coordinates of the points here where the red and the blue line meet, over here where the red and the green line meet, and down the bottom where the blue and the green line meet. So we need to find what coordinates are at each of these points. So first up, I'm going to start with where the red and the blue line intersect. So just to make things easier for myself, I'm going to label it as RB. So R for red, B for blue, and that's just going to show me what this point here, so RB on the graph there, is going to be the coordinates for that. So what we're doing is essentially setting the equations equal to each other. So my red equation is y equals 6x plus 1. My blue equation is y equals 17x take 2. And what we're doing is going to set them equal to each other and find our value of x, and then pop that back into one of the equations to get our value of y. So I'm going to go ahead and get those equal to each other. So we're essentially setting the y values equal to each other. So y equals 6x plus 1 means that 6x plus 1 is going to be equal to 17x take 2. Now, so solving linear equations, I've already done the last video on this, so I'm just going to kind of speed through this process. So I am going to subtract 17x from both sides. So we're going to have 6x take 17x, and I'm going to subtract 1 from both sides to get rid of this one here. That's going to be negative 2 minus 1. 6x take 17x, so again we're subtracting the coefficients. That's going to be negative 11x. So 6 take 17 is negative 11. And that's going to be equal to negative 3. And we're going to divide by negative 11 to get x on its own. And that's going to give us negative 3 divided by negative 11, which then we just get rid of the negative signs and we get 3 over 11. So that's a positive one. Okay, fantastic. So now that we've got that one, we can substitute our value of x back into one of our equations. We can pick either one of them. I'm going to go with the first one because it's just a smaller number, it's easier to sort of work with. So I'm going to put that back into y equals 6x plus 1, but instead of x, I'm going to write 3 over 11. So that's going to give me 6 times 3 over 11 plus 1. And then solving for that, 6 times 3 over 11, we multiply 6 and the 3 together, we get 18 over 11, and adding 1, I'm going to convert that 1 to 11 over 11 so that we can add those together easily. And then we've got 18 plus 11 is 29, and our denominator stays as 11. So I'm just going to rewrite my, so RB, again, that means that I'm looking at the intersection between the red and the blue line, and the point at which those intersect is going to be, our x value is 3 over 11 and our y value is 29 over 11. Now at this point we absolutely could put these fractions in a calculator and get a decimal value, but I want to keep answers as exact as possible, so I'm going to keep them in fraction form just to make sure that they stay as exact as possible right up until the end so that we get our most accurate and precise answer. Okay, so that's our first coordinate. Now we're going to have a look at where the red and the green line intersect. So I'm going to set y equals 6x plus 1 equal to y equals negative 9x take 4. So I'm going to label this over here. I'm just going to do my working next to this so that it kind of stays a little bit neater. So RG, so that's standing for, I'll write it down here. So, oh, that's the wrong line. RG is over here. RG, R for red, G for green. So our first equation was y equals 6x plus 1 for the red one, and y equals negative 9x take 4 for the green one. So I'm going to set these equal to each other, and we're going to get 6x plus 1 equals negative 9x take 4. I'm going to add 9x to both sides. That's going to give me 6x plus 9x, and subtracting 1 from both sides is negative 4 take 1. 6x plus 9x becomes 15x, so I'm adding the 6 and 9. And negative 4 take 1 is negative 5. Then we're going to divide both sides by 15 to get us x equals negative 5 over 15, which will simplify to negative 1 over 3. So dividing both the top and the bottom by 3. And then we're going to take that x value and substitute it straight back into one of our equations. Again, I'm going to go for the red equation just because it's a simpler calculation. So 6x, instead of x, we're going to put negative 1 over 3 and add 1. So that's just this this equation up here, that first one. 6 times x plus 1 becomes 6 times negative 1 over 3 plus 1. And expanding that out, 6 times negative 1 over 3 is negative 6 over 3 plus 1. And then negative 6 divided by 3. 6 divided by 3 is 2, so that becomes negative 2 plus 1, which means that y is going to be equal to negative 1. Negative 2 plus 1 is negative 1. So that means our coordinate where our red line intersects our green line, so RG, that is going to be at the coordinates of negative 1 over 3 and negative 1. Okay, so BG, that's going to be where the line y equals 17x minus 2 meets the line y equals negative 9x take 4. So the blue and the green line. So setting those equal to each other straight away, we get 17x minus 2 equals negative 9x take 4. Adding 9 to both sides, we'll have 17x plus 9x. And adding 2 to both sides, we're going to have negative 4 plus 2. 17x plus 9x becomes 26x. And that's negative 4 plus 2 is going to be negative 2. Dividing both sides by 26 gives us negative x equals negative 2 divided by 26. And that will simplify to negative 1 over 13. Just dividing the top and the bottom by 2 to get it in simplest form. And then once again, we're going to substitute that straight back into one of our original equations. It really doesn't make much of a difference which one we use here, so I'm just going to go with the first one. So y equals 17x minus 2. So instead of x, I'm putting negative 1 over 13 minus 2. Expanding and simplifying that one out, we end up with negative 17 divided by 13 minus, I'm going to switch this 2 to be a fraction over 13. So I'm going to make that 26 over 13. 13, not 12. And that's just so that I have equal denominators so that I can subtract these numerators nice and easily. So on the top there, we're going to have negative 17 minus 26, which is negative 43. So we end up with negative 43 over 13. And then that gives us that final coordinate where BG, so the blue line and the green line, intersect at the point where x equals negative 1 over 13 and y equals negative 43 over 13. Now, once again, we absolutely could convert these to a decimal, but because they're irrational, they're rational numbers, but they're going to be recurring decimals, and they're not going to be, they will no longer be exact. So if we keep them in fraction form, we can keep our calculations from here on out as exact as possible. So now that we've got our three coordinates of intersection, I'm just going to fill them in on the graph here. So red and blue intersected at the point where x equals 3 over 11, close, and 29 over 11. The red and the green line intersected at the point where x was negative 1 over 3 and y was negative 1. And the blue and the green, that was the last one we did, that was negative 1 over 13 and negative 43 over 13. So now what we're doing is finding the distance between each of these 3 points that we've got here. So the distance between the red, between 3/11, 29/11, and negative 1 over 13, negative 43 over 13, and negative 1 over 3 and negative 1. We're going to find each of these three distances and then add them together to get the perimeter of this triangle. Now, I'm also just going to give a little label to kind of represent what each of the side lengths are. I'm just going to call them simply R, B, and G, just for the colour of what line they are, and that's just going to help me kind of make sure that I'm not getting lost with what calculations I have and haven't done yet. So I might as well just start with the red line. So, and so R represents the distance between the coordinates where it intersects the other two lines. So R is our distance. Now we're using our distance formula, which comes from Pythagoras. So our distance formula, distance between 2 points, is given by the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so that's derived from Pythagoras' theorem, where a squared plus b squared equals c squared, where c is the longest side or the hypotenuse of a right-angled triangle. So we're essentially, so for each, we've got our two coordinates. So we've got 3 over 11 and 29 over 11, and our second coordinate for the red line is negative 1 over 3 and negative 1. So we are basically using, we'll call this x1, this y1, this x2, and this y2. So it's just saying that one of them is our first coordinate, one of them is our second, and it doesn't matter which is which. You can mix them up and do them whichever order you'd like, as long as you're subtracting the x values and subtracting the y values and making sure you square both of them. Okay, so we're going to have r is equal to the square root of the difference between our x values. So I'm going to go 3 over 11 minus negative 1 over 3 squared plus difference between our y values, so 29 over 11 minus negative 1, and that's also squared. And there's heaps of calculations you can do here. I'll go more into detail on this one, and I'll skip ahead a bit on the next couple, so this video doesn't go for too long. So 3 over 11 minus negative 1 over 3. If we're doing this by hand as much as we can, which is always a good idea, I'm going to multiply the first fraction by 3 and the second fraction by 11 to get the denominators to be the same. So 3 over 11 times by 3 is going to become 9 over 33. Negative negative here means that we're going to end up with a plus. And multiplying the second one by 11, we're going to get 11 over 33. And that is going to be squared. Then we're adding 29 over 11 can stay the same. Again, the double negative makes that a positive, and we're going to be adding 11 over 11 because 11 divided by 11 is the same as our 1 here. And simplifying that, we've still got our big square root sign. 9 over 33 plus 11 over 33. 9 plus 11 is 20, so we end up with 20 divided by 33 squared plus 29 plus 11, that's going to be 40 over 11, also squared. And at this point, I'm going to grab a calculator, and we're going to look at 20, oh no, I need brackets here, 20 divided by 33 raised to the power, oh, not quite, raised to the power of 2, and that gives us 400 divided by 1089. So 400 divided by 1089. Sorry, that's under the square root sign there. And then our second one, again, 40 divided by 11 raised to the power of 2. That's 1600 over 121. 1600 divided by 121. And then we can add those together. Again, do this on a calculator. I wouldn't expect anyone to be able to do this in your heads, or that's not quite the purpose of this exercise anyway. 400 divided by 1089 plus 1600 or 1600 divided by 121, and that gives us 13.59. 13.59. Sorry, also because I did have to round up there, I'm going to make those approximate equal signs because we're no longer working with an exact value. So 13.59, and we're after the square root of that. So we're going to take our square root symbol, that's this one here, just below the x cubed button, and we're finding the square root of 13.59, and that gives us 3.686. So approximately 3.686. Now you can round this up to 2 decimal places if you'd like. You can always make it 3.69. Doesn't make too much of a difference. I generally go for more decimal places while I'm working so that my final value is slightly more accurate. Okay, so that is the length of the red line. Now we've got to do the same thing again for the blue and the green line. I'll do these two a bit quicker so that we're not here for a very long time. Alright, second one, so we're going to do, well, let's do our blue line now. So blue, our B, sorry, I should write the points up here. So we've got 3 over 11, 29 over 11, where those coordinates and the distance from those to negative 1 over 13, negative 43 over 13. Okay, so we're looking at the distance between those points. So we've got the square root of 3 divided by 11 minus negative 1 over 13 squared plus 29 over 11 minus negative 43 over 13, also squared. Now I'm going to jump ahead and I'm actually just going to put this whole thing in the calculator. So I generally do recommend doing some simplification first, but if you're confident with your use of the calculator, it's mainly because it can be quite easy to make simple mistakes when putting really big calculations in a calculator, but if you're nice and confident, you can do that. So we've got 3 over 11, and that's going to be minus negative. Don't forget the negative here either, otherwise you would get a very different answer. So 1 over 13, and that bracket squared. Also, don't forget that you have to do both of these calculations under the square root sign. If you take the square root of each of them separately, then add it together, you're essentially just negating the squaring altogether. So make sure that you do put everything in one calculation under the square root sign. So we've got 29 over, whoops, what have I done? 29 over 11 minus negative 43 over 13, bracket squared. We're going to press equals on that one, and we get 5.954. 5.954. Oh, and again, because I did have to round that off, we're making that an approximate equal sign because it's no longer an exact value. Okay, and final calculation for our green line. So we've got our coordinates on the green line are negative 1 over 3 and negative 1, and negative 1 over 13, negative 43 over 13. Okay, so G, distance on G is equal to the square root of negative 1 over 3 minus negative 1 over 13 squared plus negative 1 minus negative 43 over 13, also squared. And then that is going to be equal to, again, remember this time we're going to make it squiggly equal signs to show that it's approximate. I'm going to clear this off and we're going to go again with negative 1 over 3 minus negative 1 over 13 squared plus, don't need a bracket there, negative 1 minus negative 43 over 13, 13, squared. Okay, and equals on that one, and we get 2.322. So that 1 needs to round up to a 2 because it's followed by an 8. So rounding to 3 decimal places, that's 2.322, approximately. 2.322. So now I have the distances for, I have the distances for each of these lines. Let's go and highlight them. We've got 3.686, 5.954, and 2.322. So now I can go in and say, finally, my perimeter, just represented by a capital P, is going to be 3.686 plus 5.954 plus 2.322. And when we add that together, we're going to get 3.686 plus 5.954 plus 2.322, and that gives us 11.962. 11.962. And it's very tempting to put a centimeters or a meters here, but because we haven't specified any units and we're just working off a graph, it's just assumed that it's units. So 11.962 is the perimeter of that triangle given by the intersection between those three lines.